So let's wrap up chapter 4 and discuss Bayes' theorem. This topic warrants its own video, so let's jump into that now. Bayes' theorem is a special application of conditional probability. This allows us to incorporate new information with the probability of something happening on top of previously known probabilities. So the probability assessment of these events of interest could be based on relative frequency or subjectivity. So here is the structure of Bayes' theorem. As you can see, it does look a bit overwhelming. We'll use a tabular approach to break it down into its smaller parts. The first step is to define our events for our business problem. Then in step 2, we're going to identify the prior probabilities, which are the probabilities that are known about the events. Then we'll define an event that if it occurs, it could alter the prior probabilities. So for instance, you got new information that affects the chance of something happening. Then in step 4, this is where we determine our conditional probabilities. Then we'll take the information from our prior probabilities and our conditional probabilities to calculate the joint probabilities. Then in the last step, we then determine what our new probabilities are, thanks to the new information that's been provided. So here is our table that we're going to be using to do the calculation for two events according to Bayes' theorem. So let's check out an example. So this is problem 4.45 from the textbook. Let's say you have parts and materials for skis made by Downhill Adventures Company supplied by two suppliers. Supplier A materials make up 30% of what is used, with supplier B providing the rest. We know then that supplier B is 70% by using the complement rule, where we take 1 minus 30%. So past records indicate that 15% of supplier A's materials are defective and 10% of supplier B's are defective. Since it's impossible to tell which supplier the materials came from once they are in the inventory, the manager wants to know which supplier is more likely to have supplied the defective materials. So the probabilities for each supplier providing a shipment of materials will be our prior probabilities. So supplier A provides 30% or 0.3 of materials. Then the probability of supplier B providing the rest of our materials is 70% or 0.7. So the new information that we have, or the conditional probabilities, is the chance of having defective materials. So we were told that the probability of supplier A providing defective materials was 15% or 0.15, and the probability of supplier B providing defective materials was 10% or 0.1. So now that we have this information, we're going to go ahead and plug it into our table. So let's input this information in for our prior probabilities and our conditional probabilities. So we're going to go ahead and plug in 0.3 and 0.15 for supplier A. Then we plug in 0.7 and 0.1 for supplier B. So to get our joint probabilities, we're going to multiply them. First, we're going to multiply our prior probabilities for supplier A with the conditional probability of defective parts. So 0.3 times 0.15 gets us a joint probability of 0.045. We'll do the same thing now for supplier B. So 0.7 times 0.1 gives us a joint probability of 0.07 for supplier B. Now, in order to get our revised probabilities, we must total all of our joint probabilities. So we'll take 0.045 plus 0.07, and this gives us a sum of 0.115. Then I'm going to use that in order to come up with my revised probabilities for each supplier. So we take the 0.045 of the joint probability for supplier A, and we'll divide it by the total joint probabilities of 0.115. And that gives me a revised probability of 0.3913 for supplier A. We'll do the same thing for supplier B. We'll take the joint probability of 0.07 and we're going to divide it by our total joint probabilities of 0.115. When I divide these two numbers, I get a revised probability for supplier B of 0.6087. So now the manager wants to know which supplier is more likely to provide a defective product. We'll just compare our revised probabilities. So we can see that supplier B is more likely to have supplied the defective parts because 0.6087 is greater than 0.3913. So what we've done is we've taken what we know in our prior probabilities, which is how much material supplier A is providing and how much material supplier B is providing. Then we added in the new information regarding the probability of defective parts from each supplier. Then we found the joint probabilities by multiplying these together, and this gives us our revised probabilities, which allows us to make an estimate for our business problem. Well, that wraps up this video covering Bayes' theorem. That also concludes our discussion on chapter 4.